2.7 is all about logistic functions. These are functions that we usually use to represent population that eventually starts to taper off. All right, so your objective is, or your essential question, sorry, how do you fit a logistic function to restricted population growth? You've probably dealt with these in maybe a science class. So the cool thing about logistic functions is you can see they're very similar to like an exponential function, but what ends up happening is maybe you start concave up and then eventually you've got this point of inflection that then turns to concave down. Notice that there are two asymptotes. So just like an exponential function, one of your asymptotes is going to be the x-axis, but this other asymptote is going to be up here, and we'll talk about where that comes from in a few minutes. Let's start with our exploration. So our exploration gives us a table of data, and it lists the population of a small community and thousands of people, and the figure shows a scatter plot of the data. So we've got the scatter plot over here. Now what we're going to do is we're going to plot this data on our graphing calculator. Using your graphing calculator, we are going to input this table of data. And then using that table of data, we are going to create this. You may want to take notes on this if this is your first time doing this. What you're going to want to do is go to Stat. Stat allows you to create a list. And we're going to edit, and you should have at least two lists. Okay, we don't need the third one. We just care about the inputs and the outputs. And if you have anything there, all you do is you just press the delete button. You can keep pressing it if you've got a bunch of stuff there. All right, and all I'm going to do is I'm going to enter all the numbers that I want for my inputs. So 1 through 10. Oops, that didn't work. Let's go back up to that one. I think I need to move this up. Oh, there's the problem. Okay, I'm going to do the same thing for my inputs by just going over to the right to my next list and entering in those outputs. Oops, got to do one at a time. Oh. My calculator is not as easy to work with as yours, so I'm messing up quite a bit here. 27, 19, 27, 32, 36, and 39. Okay, so now I have all my inputs, all my outputs. Okay, now before we plot this and get a graph out of it, you're going to want to make sure that in your y equals window, you don't have anything happening here. Otherwise, that graph's going to show up too. Now, to plot our list of inputs and outputs, we're going to hit second stat plot. So notice how the stat plot goes with the stat. Okay, so we're going to hit second y equals. Okay, now you're going to want to turn one of your plots on. It doesn't matter which one. I chose plot 1. So plot 1 is on. I'm going to press enter. If it isn't already on, if you're on off, then you're going to want to select on. The type of graph, well, you can do like a dot graph. You can do, that's a line graph. You can do a bar graph. It looks like there's even like box and whisker plots. So you got a whole bunch of different options. I'm going to choose the middle one, that line one. Make sure that your X value, let's see if I can get down there. So my X list should be the inputs, which came from L1 column. And then my Y, or my output, should be the L2 column. And I've changed the mark. You can get these big dots. You can use pluses. I choose dots, okay, like smaller dots, so that they're not protruding out of my graph. All right, and then before we graph this, let's think about our window. Oops, don't do that. Let me quit out of this one. Okay, so let me go to my window now. And it's going to be important that, we include these values. So, 1 to 10, well, I'm going to use my X minimum being 0 and then my maximum to 10. And then my Y scale, it only goes up to 39, so, and it doesn't have any negative output, so I'm going to use 0 to 40. Okay, and then when you're ready, you just hit graph. And voila, there's my graph. It looks just like this one, except for I've connected the dots. So I have plotted the data on my grapher, okay, and hopefully you took some notes on how to do that. Okay, at first, the population seems to be increasing exponentially with time. On the given figure, sketch the graph of an exponential function that would fit the first 6 data points reasonably well. And I've given you a bigger graph, this one. So the first 6 data points, 1, 2, 3, 4, 5, 6, let's create an exponential graph. So this pretty much looks like an exponential graph, but it keeps growing exponentially. Whereas you can see this logistic function starts to level off. Okay? So I think I'm done there. Toward the end of the 10-year period, the function seems to be leveling off. A function that models such population growth is called the logistic function, and its general equation looks like this. So you have x and y being your inputs and outputs. E is the base of the natural logarithm, and A, B, and C stand for constants. So the community has room for about 43,000 people, meaning that C will equal 43. Calculate A and B using the first and the 10th points. Write the particular equation and plot it on the same screen as the data. Sketch the results. Okay, we're going to use the space down here and up here to help us. And I'm going to go ahead and minimize my calculator. All right, so I'm going to use this general equation. I know C, and I can get some y's and x's. What I don't know is A and B. So I'm going to need to solve for A and B, which means I need a system of equations. I'm going to need 2 of them because I've got 2 variables to solve for. Using my first data point, 1, 2, I can write my first equation. So 2 equals 43 is what they told me C was going to be. 1 plus A times E to the negative B, and then X was 1. Setting up the other equation, using my 10th data point, 1039. So 39 equals 43 over 1 plus A times E to the negative B times 10. Okay, so now what I'm going to do is I need to work on maybe rearranging this, so maybe I can get A by itself. If not A, maybe B. Let's see which one works easier. And then whatever I get there, I can plug into this other one. Okay, so probably what I want to do first is try and solve for either A or B. I think that the best way to do that, since they're both in the denominator, is to cross multiply, get this stuff out of the denominator. When I do that, I'm going to have to distribute. So I think now I can subtract this 2. I think then I can also divide by 2. I'm just going to leave it as 41 halves. We'll deal with that when we actually pull out our calculator. I think now I want to bring b down. So what I could do is I could ln both sides. Well, now this is the logarithm of a product, which means I could actually rewrite those separately as the ln of a plus the ln of e to the negative b equals the ln of 41 over 2. Now here, this is that property, right? I've got e to what power will give me e to the negative b? Well, that's just going to be negative b. So I've got ln of a minus, that's just going to be b, equals ln of 41 over 2. So I think maybe I lied. It might be easier to get b by itself. So let me go ahead and get b all alone. So let me bring this up here. So I basically just need to subtract ln of a from both sides. So I'm negative b equals the ln of 41 over 2 minus the ln of a. But I don't want negative b, I want positive b. So b equals the negative ln of 41 over 2 plus the ln of a. Okay, so that's one of my b's. Now I'm going to take this second equation and I'm going to do the same thing. If I can also get b alone, then I can use substitution. Okay, so let's see. I'm going to take this one and I'm going to work my way up here. So I'm going to go ahead and rewrite it. Actually, I'll go ahead and cross multiply first thing when I rewrite it. So let's call that 39 over 1. I'm going to cross multiply so I get 39 plus 39ae raised to the negative 10b. Equals 43. Subtract 39. Gives me 4. Now divide out that 39. Hold on, I've got a pencil issue. So now I've got AE raised to the negative 10B equals 4 over 39. Okay, now in order to get that B down, I'm going to go ahead and take the ln of both sides. Now using that product property, I know then that this is ln of A plus ln of E to the negative 10B equals the ln of 4 over 39. Well, again, the ln of E and of E, the ln base E, or log base E of E, basically reduces to 1. You're just left with negative 10B. Solving for B, I'm going to then subtract ln of A to both sides. So I get negative 10B equals the ln of 4/39 minus ln of A, and then dividing everything by negative 10. So I get B equals ln of 4 over 39 minus the ln of A all over negative 10. So now I have two values for B, my other value being back down here. So I can substitute, how about I substitute this one in up here? Okay, so I'll draw a nice little line, show you what I'm doing. I may be running out of room. If so, we'll go on the back. I think I want to get that negative 10 up here so that way it's not trapping all this stuff so I can keep working with it. So let's see if I multiply both sides by negative 10. I get 10 ln of 41 halves minus 10 ln of a. Now these negative 10s reduce to 1, so I'm just left with ln of 4/39 minus ln of a. I might want to get all my ln of a's on one side and bring everything else to the other side, so I'll add this 10 ln of a to both sides. So I get, oh, and then I'll subtract the ln of 4/39 from both sides. Trying to save some room here. So I'm left with 10 ln of 41 halves minus ln of 4/39 equals, and this is 10 ln of a minus 1 ln of a just gives you 9 ln of a, just combining like terms there. Okay, now I'm going to divide by 9. So that ln of a is going to give me, let's see, that whole thing, mess. Okay, so basically at this point, how do I get a alone? Let's move over to the back. I'm basically going to take my base, which is e, raise it to this whole thing, and be left with a. So I'm going to have e raised to the, this is not going to be fun, 10 ln of 41 halves. It's raised to this power. Minus the ln of 4/39 divided by 9. All right, so punching that into the calculator could be quite tricky. Oh, and that's going to give me a. So I'll go ahead and do it with you. Just make sure we get the same answer. All right, so I'm going to have e raised to the, now I'm going to do 10 times the ln of 41 halves minus, which one's the subtraction? Minus ln of 4 divided by 39 and then let's see, I want all of that divided by 9. So I get approximately 36.93. Oh, let's go 931. Okay. Now I'm going to take that value of a, I need to plug it into one of my b's. So let's see here. What's the best one? How about this bottom one? B equals negative ln of 41 halves plus ln of a. So plugging this into my calculator, negative ln of 41 divided by 2 plus ln of 36.931 gives me approximately, so B is approximately 0.5886. So then my final equation becomes y equals, we had 43 was my C, 1 plus 36.931 was my A, times E, which gets raised to the B power, negative, it's always going to be negative, 0.5886, oops, times x. So that is my logistic function describing this situation. Moving on to number 4. What does the logistic function indicate the population was at time x equals 0? Okay, well, at time x equals 0, I'm just going to plug 0 in here. E to the 0 just becomes 1. Okay, so let's see. So actually, I'll go ahead and I'll do it right here. So for number 4, I'll go ahead and I'll write it all out. And then I'll go ahead and simplify. Right, so e to the 0 is just 1, so I'm just left with this. So really it's 43 divided by 37.931. Putting that in my calculator. So I get y is approximately, now this is in thousands of people, right? So, let's see, how many of these decimal places do I want to go? Thousands of people, well, 1 times thousands of people, so 3. 0.6, why not? So 1,133.6. So 1,133.6 people wouldn't really make a lot of sense. I mean, I guess somebody could be pregnant, but we should probably round up. 1,134 people will be our final answer. So number 5, what graphical evidence do you have that the maximum population in the community is 43,000? Well, if we are just looking at our graph, we could look at this graph. We can also look at the one on our calculator. But you should notice that, you know, this thing starts to level off. So at year 10, I'm at 39,000, and this thing appears to keep growing, but not growing very fast, right? So it appears to be leveling off around 43,000. Oh, I guess I should say graph levels off. I'll say approximately. Look up the word logistic in the dictionary and find the origin of the word. Well, like most words, it comes from Greek, the Greek word logos, which means word or calculation. I'm going to put means calculation. And I'll let you finish number 7. What did you learn as a result of doing this exploration? Now moving over to the rest of our notes, let's just go ahead and finish this up a little bit. Okay, so again, going from concave up to concave down. Now, that's not always going to be the case, okay? You could have something that starts off with a high population and then starts to approach 0, okay, but never quite gets to 0. Okay, so if B is greater than 0, you go from that concave up to concave down. However, if b is less than 0, you're going to go from the concave down to concave up. Now, you're going to have an asymptote. So that asymptote, like our asymptote on our exploration, was 43,000 people. Okay, and you're going to have that asymptote. Well, where did that come from? Let's go back to our exploration. So where in here do we see 43? Well, 43 was our C, right? So your upper asymptote comes from your C. So the asymptote up here is always going to be where y equals C, where y equals C, okay? So I think that, you have a couple of important things here. You've got the general equation for a logistic function. I would add that to your parent graphs. The domain is going to be all real numbers, okay? But you will have some constraints on your range depending on those asymptotes. You have two horizontal asymptotes, one at y equals 0 and the other at y equals C. And then your point of inflection is halfway between the two asymptotes. So basically you take C divided by 2, and that's where you're going to find your point of inflection.